Hey, last time we configured a mine transactions endpoint in the API to allow the requester to mine a block of transactions. The behavior is almost perfect. It grabs the valid transactions, makes a reward, adds a block consisting of all of those transactions, broadcasts that block, and then clears the local application's transaction pool. There's one crucial thing missing though. The only transaction pool that clears is the one where the mine transactions request was made. But we also have to make sure that the transaction pools all across the network aren't holding on to any transactions that are now within the blockchain. To do this, we're going to want to call our clear blockchain transactions method from the transaction pool once the blockchain has been successfully replaced. So to run code, once a replace chain has succeeded, we're going to add a new parameter to the replace chain function called onSuccess. So within blockchain/index.js, in the replace chain function, we're going to have a new parameter called onSuccess. And we're going to make an exception to the TDD approach in this case and write the test last. Since we've seen this issue primarily in Postman, we're going to use Postman again to check that the solution addresses the issue in the same way. Okay, onSuccess represents a callback function. So we'll only call this if we make it to a successful chain replacement. So right before this console.log, we're going to call the passed in callback of onSuccess. However, we don't want to make it a requirement to have to call onSuccess if it doesn't exist. So we'll only call onSuccess if it's actually defined, which we can capture with an if condition around the onSuccess name itself. Nice. Now this allows us to pass in functionality that we want to call when a replace chain function is successfully completed. So the one case where we're calling replace chain within application code is the pubsub.js file. We call replace chain on a channels.blockchain message. So in this case, we're going to want to pass in a callback function on a successful replace chain that we're doing through the pubsub class. And in the onSuccess case, well, we want to clear this local transaction pool of the existing blockchain transactions now. And this is because, well, if we're calling replace chain, that is because we're trying to replace the blockchain with a new chain that's been contributed in the network. The idea is that we're going to clear the local transaction pool of any transactions that were included in this parsed message chain. So we'll call this .transactionPool.clear blockchain transactions right within the callback that we're passing in to replace chain. This takes a chain as its argument within an object, and the chain itself is the entire parsed message. So we're going to pass that in to this .transactionPool.clear blockchain transactions. And now this code should take care of the job of making sure that all the transaction pools are cleared across the network when a blockchain is broadcasted and successfully replaced. So go ahead and open up the command line once you have those changes. In one tab, I'm going to fire npm run dev to get the main node going, and in another tab, I'll fire npm run dev peer to get a peer instance. Now make a note of your peer address. Mine's a pretty cool one, 3636, so I'll be sure to use that when I make request to the actual instances through Postman. So go ahead and open up Postman. First up, we're going to want to make a couple transactions. So fire a post request at localhost 3000/API/transact. Do this a few times at the same address and experiment with other addresses and other values if you like. Make sure you have valid JSON as your body, so double quotes for everything except for the number, which is the exception, and arrays too. So this should make a transaction object, and indeed it is there. The next thing we want to check is the transaction pool map, and I'm actually going to hit the root transaction pool map first. So localhost 3000/API/transaction pool map. And then this one is still there because, of course, I need to make a mine transactions request. So once we make the mine transactions request at the root node, well, you'll find that you get redirected to the blocks, and indeed that transaction that was created before is now included in the blockchain. All right, cool. There's even the authorized mining reward. That's really nice to see. But now for your request for the transaction pool map, this should indeed be empty. And that was already existing behavior. The change that we implemented is to make sure that now also the peer has been cleared of its transactions in the pool as well. So my peer address is 3636, but go ahead and plug in the one that is logged on your peer. And once you're ready, click that send. And what you're going to find is hopefully, well, the connected peer is empty for its transaction pool map. Nice. That's because it cleared its pool of the transactions that are now being recorded within the blockchain history. Nice. So this should take care of clearing the transaction pools across the entire network of all recorded transactions once they're in the blockchain history and the chains have been replaced, including those transactions within the chain data itself. All right, now that we have this transactional data successfully recorded in the blockchain, we need to make sure that wallets accurately reflect their balance based off the blockchain history. When a wallet receives currency at their public key, and once that transaction has been included in the blockchain, they should be able to add that currency to their balance. So let's do that next.